Well, I just felt like walking through another paper. This is a walkthrough on a mock paper from a physics factory website. I have no commission from the website. I just found out the paper, and the paper I'm doing here, I'm going to blind solve it without having seen it again. I'm going to time myself as well. And I very much hope that the walkthrough will be useful for you guys. Please help support me by like or subscribe, or do both if you love me. See you in there. Now here's the paper that I mentioned. This is mock paper set 2. And I'm gonna start the timer now. Okay, let's go. Number 1, logarithm. Okay. Part A. Hang on. Given that blah blah blah, show that blah blah blah. Alright, so this is straightforward. We're just gonna use the log property so that we pull 2 in front of the log there as the power like that. First, right, equals 0. And then we're going to combine the log terms using a log property. So if you have log A minus log B, that is just going to be log A over B like this. Yeah? And then that is still equals 0. Now, if we want to undo the log here, we just take log to the other side, and that will become, because if you don't see any base here, that means base 10 automatically. Yeah? So you can undo the log by just moving it to the other side, and that will become 10 to the power of 0, basically. But you know, whatever the base is, when you power that by 0, it will become 1, right? So I'm just going to write this as 1 actually, yeah? And then, well, we're going to have to simplify this, and we need to show that it is a quadratic, right? So if I also multiply 21 minus 2x on either side, and then I expand that 3 minus x brackets squared there. So I get 9 minus 6x plus x squared, right? That's the left-hand side, okay? And then plus 21 minus 2x here, yeah? And then if I move everything to the same side, I get x squared minus 4x minus 12 equals 0. And that is as required, right? That's part A done. Part B. I write down the roots of that. So the roots of that will basically, yeah, we can just do a bit of factorization. So I'm just going to do x minus 6 times x plus 2 equals 0. So the roots would just be 6 and minus 2. Okay, yeah, 6 and minus 2 for that. And which of these two roots is not the solution? Right. It is important to verify your answer here by plugging them back into the log equation here, right? So if you plug it back to the log equation, 6 here, this is going to be a negative inside the argument of the log, right? And that will, if you try throw that to the calculator, it will throw you back an error. So let's do log minus 3, right? That is undefined, yeah? So, I mean, only that doesn't work. If we try minus 2, of course, that's going to be plus. The 2 works, but the minus 2 works, sorry, but the 6 doesn't. So which of these roots is not the solution of that? So we say 6, yeah, is not the solution. You got to be careful that it asks for the one that is not the solution of the equation, yeah, because it asks for the answer as well. Sorry, it asks for the reason as well. Because when substituting back, we get log of 3 minus x. So that's just going to be log of 3 minus 6 squared, which is log of minus 3 squared. And that is, okay, log of minus 3 is undefined, right? So undefined is the keyword, yeah? You can't take log of a negative number, basically. That's it. So that's the whole question A done. Next question, question 2. Given that function, given that y equals fx has a single turning point at x equals alpha, A show that alpha is a solution of the equation, right? So, well, we can see that on the right side of the equation, we have a cubic, right? We know that we have a cubic. Let's see. Okay. I mean, honestly, sorry. This is a turning point, right? So we need to differentiate first. So we differentiate f dash x equals, so differentiating 3x to the 4, we get 12x to the 3. Differentiating 2x squared, we get 4x. Differentiating 12x, we get minus 12. And that will go to 0, the last one, okay? And we put this to 0, yeah? And the solution to x will be alpha, okay? And it says has a single turning point, right? Okay, well, for the time being, let's just say that we're going to make x cubed the subject first. So that's going to be 12 minus 4x, all divided by 12, yeah? And as you can see, we have x cubed, 1 minus x over 3, yeah? And if we cube root both sides, we get what they want there. There you go. Okay, so that is as required. The iterative formula, blah, 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 is used with x equals 1 to find an approximate value of alpha. Okay, B, that was A. B, calculate the value of x2 and the value of x5. Well, we got to keep going, right? Giving each answer to 4 decimal places. For this occasion, I need to use the other calculator. Hang on. Okay, there you go. So you probably might not see the top line there, but I'm just going to narrate when I press the calculator. So I'm going to make 1 to be the answer first. So I stored that already. That's x1. So we're going to write x2, x3, x4, x5 here. Yeah. We know that it's 4 decimal places. So cancel. And then I'm going to do cube root. Yeah. 1 minus answer over 3. Okay. Is that cube root? Hang on. That's not a cube root. Sorry. Okay, hang on, let me do that again. Cube root, yeah. 1 minus answer over 3. Is that right? Yeah. So my x2 is just 0.4 decimal places, 873 6, right? 4 decimal places. And then if I enter again, actually I just had to enter once to make it store, and now enter again to make it do the next one. So this is actually x3, yeah, 0.8916. Do it again, 0.8891. Do it again, 0.8894. Okay, so that was all it is until x5. All right, so I'm going to keep that first. And then that's part B done. Using a suitable interval and a suitable function that should be stated, show that to 3 decimal places alpha is that. Okay, a suitable function, yeah, we're going to use one of these. So before that, you need to make one side equals 0 first. So a suitable function, let's say gx, because they already have fx there. So gx equal, you're going to make one side become 0, and you will take the side that is not 0. So I'm going to do x minus, yeah, cube root of 1 minus x over 3. Basically, it is just this equals 0. Basically, just that. Yeah, it's just the f dash x equals 0. You can take this one. Yeah, you can also take this one. Let's take that one, right? But it's the same thing. So I could also take the derivative one. Yeah, because we're going to put this to 0 as well. That means the iterative formula there, when you keep pressing the calculator, it should be, when you do the change of sign, it will yield the same kind of result where you get a change of sign, right? So we need to state the function here first. This is the function. We're going to check the interval, all right? And now we do check the interval. So we put g, a suitable interval, right? So the interval we're going to use, because this is 0.889 to 3 decimal places, so we got to go to the 4th decimal place, which is 8885, right? And the other one is 0.8895. So just add one more, and the extra decimal there will be 5. 5 smaller and 5 bigger, if you know what I mean. Yeah, so it's the 0.0005 smaller to get the lower bound, and 0.0005 greater to get the upper bound, right? And then we're going to do g of 0.8885 there, and g of 0.8895, yeah, those two. Okay, let me just move everything to the right a little bit because I need a calculator here. Okay, so let's do 0.8885 store, and then 12 times answer to the power of 3 plus 4 times answer minus 12. That is a negative, which is minus 0.0291, yeah? And if we change everything, sorry about that, 0.008, no, 0.8895, right? Store, and then do 12 times answer cubed plus 4 times answer, right? And then minus 12, yeah? So that gives me 0.00338. I'm just going to leave it at that. Okay, so here we can do our thing here. There is a change of sign, yeah, of gx, while gx being continuous in the interval 0.8885, 0.8895. So there is a root alpha in between, and alpha equals 0.889 to 3 decimal places. That's how we do it, yeah? 2 marks. Okay, so that's question 2 done. Next, question 3. What do we have here? Figure 1 shows a plain view of a design for a stage at a concert. The stage is modeled as a sector BCDF of a circle center F joined to 2 congruent triangles, ABF and EDF, so those are the ones on the sides there. Given that AFE is a straight line, yeah, AF is 10.7 AF, yeah, so FE is also 10.7 here. BF equals FD, so this is just probably the radius, yeah, because this is BCDF is a sector, so it's saying the radius is 9.2 basically. The angle BFD is 1.82, so the angle of the sector there is 1.82. Okay, so part A, the perimeter of the stage, everything, we want to find the perimeter of the stage in meters to 1 decimal place. Alright, so it's just 2 of the AB here, and the sector, the arc length of the sector, and then this guy right here, AE, okay, which we already know. So it's 2 of the AF, which is 10.7, yeah, from A to E here, 10.7, 2 times, because each one of them is 10.7. And then this side here, AB. Now this one, right, AB, we haven't quite got. Yeah, okay, so this one might need some more work. So the sector is fine. Now let's find the arc length of the sector first. So BCD, that's the arc length, equals, arc length is r theta, right? So r is the radius, which is 9.2, yeah? So that's 9.2 times theta in radian, yeah? Angle BFD here, 1.82. Okay, so that's going to be 9.2 times 1.82. 16.744. I'm going to keep everything first. And then we have what? The AB here. All right. So because the two triangles are congruent, we got to find each of these angles here, which will be the same. Yeah. So that angle there, we say angle AFB equals, well, because AFE is a straight line, so that whole thing is pi minus this angle here of the sector, which is 1.82 radian, and divided by, because we need to share, need to share that into halves because there are two sides. Okay. After we got that angle, we're gonna, let me keep it like that in exact form. So I prefer keeping in an exact form like that. Now we're gonna use this to find the side AB, right? Because is there a way to find it more quickly? Probably not, because we know that this is side BF, which is the radius. We know this angle, right? So how do we find, oh, we know AF. Yeah, we know this side, we know this side, we know the angle here, so we can find the AB using cosine rule, right? So using cosine rule here to find, I'm just writing here, find AB, right? So use cosine rule, AB squared, or I'm just going to do square root already. AB is each of the sides square and add up, right? So AF is 10.7 squared plus BF squared, 9.2 squared, minus 2 times both of them, and cos theta. This is cos the angle there that we just got in radians, of course. And this is all square root. This is all in the square root, right? So in the square root there we go. Okay, so that's just AB. And we're going to find the perimeter here, P, okay? So after we got AB there. So square root, I'm just going to change my calculator so that you guys can see as well. Okay. So in square root, right? What was that again? 10.7 and 9.2. So 10.7 squared plus 9.2 squared, right? Minus 2 times 10.7 times 9.2, okay, 10.7, 9.2 times cos, got to change that to radian, fraction, pi minus 1.82 divided by 2, so that's the answer there. That's 6.610. Gonna keep it as 3 decimal places, okay, which is fine because they want 1 decimal place as the final answer. So perimeter is 2 of the 10.7s, and then plus the arc length, which is 16.744 above, and then plus I got 2 of the arc lengths, and then 2 of the ABs. So 2 of the ABs, which is 6.610. Wait. So okay, the AF here is just 10.7, just checking, that's fine, right? 5, okay, and then we're gonna plug that into the calculator, so I can just do equal and clear because I already got that. So 2 times answer plus 16.744 plus, what was that, 2 times 10.7, so that's 51.364. That's just 51.4, meters, and this is just 1 dp. Okay, so that's part A. Part B, find the area of the stage in meters squared to 1 decimal place again. Okay, we find perimeter and area here for the whole question, right? So B. All right, so but we got quite a lot of information already. So it's just the two of the triangles and the area of the sector. So the area of the sector is just 1/2 the radian, which is 1.82, the angle is 1/2 theta r squared, yeah, or 1/2 r squared theta, whatever, yeah. So it's 1/2 theta times r squared. R is BF, which is 9.2 squared, yeah, plus 2 times the triangle. Now the triangle, right? We just gonna use 1/2 AB sine theta. 1/2 times A. I'm just gonna go with the same triangle here. So A is AF, B is BF, and theta is just that old angle we got earlier. Okay, so 10.7 here times the other one, which is 9.2 times sine of all that ABF angle there. Yeah, I'm just gonna copy that down. There you go. All right. So we're just gonna work that out. So what was that again? Just gonna move it here. 0.5 times 1.82 times 9.2 squared plus 2 times 0.5 times 10.7 times 9.2 times sine, and this is already in radians, so I'm fine, pi minus 1.82 divided by 2. There you go. I think I'm fine with all the pressing calculator thing. I'm just going to double check once more, and if I'm good, I'm just going to go to the next part. Yeah, you should always do like this. You should check every time, because calculator is tricky sometimes. I mean, it's not meant to be tricky, but if you're not careful, it is tricky. So it's 137.4 square meters. Therefore, yeah, that's the answer. Okay, so question 3 is done. Next, question 4. All right. Figure 2 is a sketch showing the line L1 with equation y equals 2x minus 1 and the point A with coordinates -2, 3. The line L2 passes through A and is perpendicular to L1. Okay, find the equation of line L2, writing your answer in the form of that. This is not hard, straightforward. So if it's perpendicular, the gradient is then -1 over the other gradient, right? So the gradient of line L2 is just then -1 over 2, because the gradient of line L1 is 2, right? And then passing point A, we just use y minus y1 equals m x minus x1. So y minus y1, we're just going to take point A because line L2 passes through A. So y1, which is the y coordinate of A, which is 3, equals m minus 1 over 2, x minus x1, which is +2. It's minus 2, yeah. If we multiply across by -2, we're going to get -2y plus 6 equals x plus 2, yeah? Because that will cancel the minus sign as well, so I just get x plus 2 there, yeah? So moving everything to the same side, we're gonna make it y equals mx plus c. Oh, I shouldn't have done that, hang on. So -2y. If I move y to, well, okay, let's do 2y equals x minus 4. So y equals -1 over 2x, yeah, plus 2. And that makes sense because a sanity check here, the gradient should be what we expect, okay? Yeah, that is fine, okay. That's part A there. Part B. The point B and the point C lie on L1 such that ABC is an isosceles triangle with AB equals AC equals 2√13. B show that the x coordinates of points B and C satisfy the equation. All right. So if I can draw a little diagram myself, yeah. Okay, so that's line L1. Line L2, so if we look at line L2, right, it passes, so the y-intercept is 2 here. So that's about maybe something like here, and the perpendicular, yeah, it's just that. Okay, that's nice. Okay, this is L2. Okay. AB, okay, A is there, minus 2, 3, yeah, this is A. It says B and C lie on L1, such that AB equals AC. Okay, so maybe something like this, I guess. Yeah, so that you get an isosceles like this, ABC. All right, so ABC is an isosceles triangle with AB equals AC. Yeah, all right, makes sense. Show that the x coordinates of point B and C satisfy that. All right, now note that B and C are both on L1. So whatever their coordinates are, they must satisfy the equation of line L1, which is y equals to x minus 1, right? And so we already know the coordinates of minus 2, of A, which is minus 2 and 3. Okay. Let me process this a little bit. I mean, the line L2 is not any use, right? Yeah, it's fine. Isosceles triangle. Okay, interesting. Right. Okay. So we're just gonna make this x, and the y coordinate will be 2x minus 1. So basically just substituting y as, so substitute 2x minus 1 into the y there. So we get x and then 2x minus 1. So if we find the distance of A to C, we should get 2 root 13, right? So distance AC here equals the Pythagoras of minus 2 minus x, yeah, squared, plus 3 minus 2x plus 1. Just do the sign expansion there, you should get that. And then what is this? Well, if we square root that, we get 2 root 13, right? So if we square both sides, the square root will be undone. So we have, if we expand both terms, right, we get x squared plus 4x plus 4, yeah? Like all the minus signs will just disappear because there's a square here. And then plus, well, this is actually, what is that? 4 minus 2x, right? So we just get 16 minus 2 times 2 times 4, that's 16 as well, yeah? X, and then plus 4x squared. The right side will be squared, so we get 4 times 13, and that is 52, isn't it? Yep. So on the left-hand side, we get 5x squared. The x term will be minus 12x. And then this is 20. 20 minus 52 is minus 32 equals 0. Aha, exactly what they want. Okay. Part C. Given that B lies in the third quadrant, B in the third quadrant, yeah, we got it right. Yeah, there you go. Find, using algebra and showing your working, the coordinates of B. Righty. Well, I think we just solve this quadratic, right? And we'll get 2 answers for C and for B respectively. So I'm just going to factorize that quadratic. See what I get there. Let's see. Okay, so 8 and 4. 8 and 4, yep. 8 and 4 here. So this is minus, this is a plus, right? Yep, that's right. Okay, so x equals minus 8 over 5 and 4. Because it's in the third quadrant, so x should be negative. Yeah, so xb is minus 8 over 5. And we want to work out the coordinates of B. So if we, because B lies on the line L1. Okay, B is on L1. That means we can plug coordinate of x of B into this to get the y. Yeah, or the equation of line L1 that you can see. Yeah, so L1 again, y equals 2x minus 1, so 2 times minus 8 over 5 and minus 1. Yeah, so yb will be minus 16 over 5 and then minus 5 over 5, so that's minus 21 over 5, right? Yeah, just checking. Yep. Okay, so the coordinates of b will be then minus 8 over 5 minus 21 over 5. Answer. Okay, so that's it for this one. Let's go to the next question. Number 5, vectors. Wow, okay, intriguing. Well, maybe not. Vector AB and BC are given by that and that, where P and Q are constants. Given that AC is parallel to that, find the value of P and the value of Q. Okay, so AC seems to come from AB and BC, because if we do vector addition, so AC is just AB plus BC, right? If you notice here, the inner letters are the same, and we look at the outer letter A and C here to get that. Yeah? So this is 2PQ4 plus Q minus 3P2. So 2P plus Q, we don't get anything, so it's just 2P plus Q. Oh, this is Q. I gotta be careful with my handwriting there. Otherwise, I'm going to fool myself. Okay, so this is Q minus 3P, and then 4 plus 2 is 6. So it's not a lot more simplified there, just, you know, some algebra. I'm just checking. Okay, so now it is given that AC is parallel to that vector. So we're going to put it to some multiple and that vector there times that vector. Okay, that's the definition of two vectors being parallel. Okay, so that means we can solve simultaneously here. Maybe we can find k by the k component first, like the last component at the bottom. So 6 equals 3 times k here, just 6 and 3 times k here, yeah. So we get k equals 2 by that. And then, yeah, we gotta solve simultaneous here, because if you look at the first and the second row, they don't quite have, you know, such that you can solve one of them directly. So we're gonna write 2p plus q equals k times 3, 2 times 3 is 6. Yeah, that's equation 1. And then the other one is, I'm just going to write minus 3p plus q here as well. Yeah, is minus 3p plus q, yeah. Equals 2 times minus 4 is minus 8. Well, if you subtract both equations like that, just like column subtraction like we did in like primary school, yeah. 6 minus minus 8. 6 minus minus 8 is 14. Q go away, yeah. And then 2p minus minus 3p, we get 5p, right? Okay, so we can solve for p first. It's just 14 over 5. Okay, and then we solve for q. So q will just be minus 8 plus 3p, right? I'm just using this one. So it's 14 over 5 like that. Let's see. Okay, calculator maybe. So minus 8 plus 3 times 14 over 5. Is that? Yep, 2 over 5 there. Okay, so that's done. P and Q. Done for vector. Not that bad. Next question, number 6, right? Okay. A small company which makes batteries for electric car has 10-year plan for growth. In year 1, the company will make 2,600 batteries. In year 10, the company aims to make 12,000 batteries. In order to calculate the number of batteries it will need to make each year, from year 2 to year 9, the company considers 2 models A and B. The model A, the number of batteries made will increase by the same number each year. So that is indicating arithmetic sequence, right? Using model A, determine the number of batteries the company will make in year 2. So this is just asking a particular number in the sequence, not the sum, right? You gotta be careful. So we write AN equals A plus N minus 1D, right? That's arithmetic sequence there. And year 1 is just 2600, right? Yeah, but in year 10, okay, in year 10, A10 is 12,000, okay, and n equals 10 here. So that is to find the d. So d is just A10, 12,000 minus A1, which is 2600, divided by 10 minus 1. Yeah, just to find d. So I'm just rearranging this equation to make d subject, basically, to solve for d first. So d is just, what is that? So fraction 12,000 minus 2600 and divide by 9. Ooh, okay. The number is quite weird here. Let's see. I'm just checking first, see if there's anything weird here by the same number. Okay, because it doesn't say the common difference, right? The d here, so we need to find, because in year 10 it's 12,000. Just checking if I didn't make any mistake, right? And that should be fine. That should be fine. Okay, so I'm just gonna take that number, but I keep it as a fraction, yeah, to keep it exact. So we want to find A2, right? So that's just A1 plus, just one of the common difference, which is that. And I'm just going to add that by, 2600. So that's in year 2 already. Yeah. And that is just 32,800 divided by 9. So let's make that 3644. Yeah, battery, if you round that to nearest integer. That's part A. Part B, in model B, the number of batteries made will increase by the same percentage each year. So that is indicating a common ratio for the geometric sequence. Using model B, determine the number of batteries the company will make in year 2. Okay, again, so we have AN again, just going to use AN, n times r to the power of n minus 1. So if we sub everything in, yeah, in this case, again, A10 is 12,000 equals A1 is 2600 times r to the n minus 1 will be 9, right? Because that's 10 minus 1. And we're going to solve for r. So if we do everything, okay, I'm just going to write r equals 12,000 over 2600, the 9th root of that, yeah? So 9th root, well, I'm just going to do, oh, we have this one. Okay, 9th root, fine. 9th root of 12,000 divided by 2600. So that's just 1.185225. Just keep precise first. 1.185225. Yeah, just checking. So that's the common ratio. And again, we want to find year 2. So A2 is just 2600 times that to the power of 1, right? Because that's n minus 1. So we're just going to basically multiply this thing by the first term to get the second term. And I'm going to round that to the nearest integer. Yeah. Okay, to the nearest, hang on. To the nearest 10 batteries. All right, nearest 10 batteries there. So nearest 10 batteries would be 80. Yeah, like that. Yeah, now I start to wonder if I got that one right. But yeah, it should be fine. It's a fraction. I mean the part A. Let's see. Part C. Sam calculates the total number of batteries made from year 1 to year 10 inclusive using each of the two models. Calculate the difference between the two totals, giving your answer to the nearest 100. All right. So for model A, so that was just S10, right? Year 1 to year 10 inclusive. Okay. So the first term was 2600, and the last term is 12,000 divided by 2. So I'm using a plus last term, first term plus last term divided by 2 times the number of term, which is 10, right? Yeah, so that's easier to use. So it's 2600 plus 12,000 divided by 2 times 10. So that's 73,000. Yeah, that's model A. For model B, which is geometric, so S10 is, what's that? So A, which is the first term, 1 minus R, which is 1.18525 to the power of n, which is, let me just check the formula sheet, right? Somehow I kind of like, forget this formula time to time, which is the sum of sequence. I shouldn't be forgetting that. I mean, sometimes I do, but yeah, there you go. It's a n minus r to the n over 1 minus r. Yeah, that's fine. Just checking. To the n, right? So to the n is 10 over 1 minus r, which is also 1.185225. Okay, so we should get the value there. So 2600 times, just going to do fraction here, 2600 times 1 minus 1.185225 to the power of 10, close brackets, and then here 1 minus 1.185225. Everything is fine, right? And then we get the answer as that. Okay, now, yeah, that's quite different, right? Calculate the difference between the two totals. Okay, so difference between A and B, delta S different, is just 73,000 minus 62748.97 there. So we're just going to do that. 73000 minus answer. Wow, okay. So yeah, that's about that first, and then they want to the nearest 100 batteries. So it's just 10,200. No, 300. Almost. Rounding error, guys. Okay, that is the answer there. Okay, I think I'm okay with it. Next one is question 7. Right. Gx is that where a and b are constant, given that 2x plus 1 is a factor of gx. The curve with equation y equals gx has a point of inflection. Okay, yeah, haven't quite seen this coming out. At x equals 1 over 6, right? So part A, find the value of a and the value of b, right? So first we use factor theorem because we got 2x plus 1 as a factor. It's called a linear factor. So the critical value would be minus 1 over 2. So you just equate 2x plus 1 to 0, you get minus 1 over 2 when you solve for x. And then you put that as a critical value, you sub in the gx function here. And then that should be equal to 0, right? So this is to the 3 plus a minus 1/2 squared plus 4 times minus 1/2 plus b equals 0. Just going to move that a little bit. Don't want to squeeze too much there. Okay. Just checking the substitution here. Yep, that's fine. So so minus 1 over 2 to the power of 3 is minus 1 over 8. So that's minus 1/2. Yeah. Okay. And that's plus a over 2. This is minus 2 plus b equals 0, right? Okay. So of course, it looks like we're going to get simultaneous equations. So if we multiply across by 2, we get a here. And if I sum this up first, I get minus 5 over 2. So that's minus 5 plus 2b equals 0, right? Because I multiply by 2 for every term. Yeah, so that's the first equation. And now about the inflection, right? So we got to differentiate twice and equate that to 0. So this inflection is where the second derivative equals 0, right? So the first derivative is just differentiating all that. We get 12x squared for the first time plus 2ax plus 4, and b goes away, which is convenient because we now can solve for a, right? Let me just check my derivative again. Yeah, everything is fine. So we're going to differentiate again. So that's going to be 24x plus 2a, and the 4 goes away. We're going to equate this to 0, and because it happens at x equals 1 over 6, right? So that's going to be 24 1 over 6 plus 2a equals 0. Yeah? So 24 over 6 is 4, so a is just minus 2 if you solve that equation. I think you're okay with that? All right? Yep, so a is minus 2, so that means b is, what is it? 5 minus a, which is minus 2. I'm just solving this one, basically. Minus a, which is minus 2, over 2. So that is just 7 over 2. Yeah? So b equals 7 over 2, a is minus 2. That's it for the two values. Okay. Part B, show that there are no stationary points on the curve with equation y equals gx. So, I mean, usually to find a stationary point, we just do the first derivative of the function equals 0, right? Because the gradient is 0. Now, of course, we have already done the g dash there. So this is just, and a is already minus 2, so that's going to be minus 4x plus 4, right? So we need to show that there are no stationary points. That means there are no answers to this one. So if we do b squared minus 4ac, we're going to get minus 4 squared minus 4ac. Yeah, so that's 16 minus, what's that? 16 times 12. So that's, isn't that like 196? Yeah, let me just check. 16 times 12, yep, 196. And minus that, so we get minus 180, which is less than 0. So this is saying that b squared minus 4ac less than 0. So it's no real roots. Yeah, for this, that means no stationary point. Yeah, because there's no solutions when we equate derivative of g equals 0, right? And that's it. Next, question 8. Part A. Sketch the curve with equation that, where k is a positive constant, state in terms of k the coordinates of any points of intersection with the coordinate axes and the equation of the horizontal asymptote. Alrighty. So we're going to just sketch by ourselves because I don't have graph paper. That's fine. So k is a positive constant. That means the y-intercept is around k maybe. And this is a negative gradient line, so I'm just going to do that. That's easy. And then, hang on. So that should be like this more, yeah, to make it make sense. All right. And if we want to find the x-intercept, we equate y to 0. So 0 equals k minus 1 over 2x. So 1 over 2x equals k. So x equals 1 over 2k, right? Yeah. So that is 1 over 2k there. And the y-intercept is already, wait, hang on. This is not a linear equation, all right? Okay, I'll do it again. Somehow I thought this is linear equation. It's not. This is a reciprocal function, right? Sorry. Okay. Because the moment I realized when I substitute x0, that doesn't work because it would give me a division of 0. So I realized I went wrong with the function there. Okay. Usually, if you have reciprocal function like y equals k over x, you're going to get that, right? We're going to work by transformation here. Now, if you put a minus sign, well, in this case, let's start from 1 over x, yeah? Y equals, well, let's say 1 over 2x. It's just the gradient there. I mean, it can be 1 over x or 1 over a million x. Doesn't matter. It's going to look the same. It's just slightly different in terms of the gradient of the line. But if we put a minus sign, Yeah, let's put a minus sign here. It's gonna flip, so everything will flip. This will go up instead, and this will go down. Yeah, instead of quadrant 1 and 3, we get now quadrant 2 and 4 instead. Okay, and if you add k, right, the thing will shift up. From before, you have the asymptote, horizontal asymptote being the x-axis. Now it's going to shift up. And the horizontal asymptote of the x-axis, if it was the x-axis, then it would be y equals 0. Now, being shifted up, the horizontal asymptote will now change to y equals x, just, you know, by the same amount of transformation there to the graph. Yeah? And we need to find the points of intersection with the axis. Oh, the horizontal asymptote is that, the vertical asymptote is x equals 0, it doesn't change. Okay, now let's find this, right? Okay, how do we work out this? Well, that is when x equals 0. Sorry, y equals 0. So that was just the work I did before. Just doing that. And then k equals 1/2 x. So x equals 1 over 2k. Yeah? So that's 1 over 2k there. Okay. Right? So that's it. Everything. 3 marks for part A here. Yeah, I think I got everything. Part B. Straight line L has equation that, given that L cuts the curve with 2 distinct places. I mean, they could have just used points. B, find the range of values of k, writing your answer in a set notation again. Okay, so this is a straight line, and it's a positive gradient straight line, and the y-intercept is 3. Let's say about that. Ooh, 2 distinct points, right? Interesting. How do they cut there? I mean, it doesn't look like they do cut, but interesting, very interesting. Okay, I mean, I might have drawn the graph wrong here, right? So maybe it should be, okay, this is difficult now. Okay, I mean, if they were to cut, maybe it's gonna look like that. Yeah, more like that, because I mean, the line can't cut this half. We can't really make them cut like 2 points. The only possible way is that the line looks like that. Yeah, and cut 2 points on the left wing of the curve there. So we're gonna make the line look like that maybe. And this is actually 3, and they cut these 2 points. All right. Okay. So, well, actually, we're just gonna equate them. So we do 2x plus 3 equals k minus 1 over 2k. And this is just done by solving this, right? So how about we multiply 2x on every term? So we get 4x squared here, yeah? And we plus 6x here, yeah? Equals 2kx here and minus 1, all right? And then if we rearrange, so we see clearly that this is quadratic. I'm just going to merge the term x there, like that, and plus 1 equals 0 like this, yeah? Because for the sake of substituting it into the quadratic formula, that's easier. Okay, and 2 distinct points. So the discriminant must be greater than 0, right? So b squared minus 4ac greater than 0, okay? Right, so expanding all that, right? We got no choice, I guess. 36 minus 2 times 2, 4, 4 times 6, minus 24k plus 4k squared, and that's minus 16 equal greater than 0. And then we have here 4k squared minus 24k plus 20 greater than 0. If we divide across by 4, we get this, right? Yeah. And then if we factorize that, we get k minus 1 and k minus 5 greater than 0. Well, in a set notation, well, let me just put in an inequality form first. So that's just k greater than 5 or k less than 1. So we want to do set notation. This is just the set of k where, yeah, k is greater than 5, union a set of k where k is less than 1. Yeah, so that's a set notation. If you have an or, then you probably have to separate the two sets and writing a union in between. Okay, I think I'm fine with that. And that's it for question 8. We're at about an hour now. We should be fine. Okay, question 9. Figure 3 shows a sketch of part of the curve with equation that. Okay, this is exponential. Probably have to integrate that. Okay. A, find the value of A and the exact value of B. Okay, it says point PAB is the turning point of the curve. Yeah, we can see from the graph there. So turning point, right? Again, we find the derivative of y dy by dx equals. That looks like we need to use product rule. So u and then dv, which is minus 2 e to the minus 2x, that's dv, plus v du, so du is just 1, so it's just e to the minus 2x. Yeah. Okay, I'm fine with that. And then we equate that to 0, classic, and then we solve that. So if we factorize e to the minus 2x out, I'm going to get minus 2x plus 1 like this, equals 0. I mean, e to the minus 2x doesn't have any solution, right? I mean, it doesn't equal 0. It can never be 0 anyway. Any exponential cannot be 0, right? So that means the only solution is from minus 2x plus 1 equals 0 and x equals 1 over 2, right? Yeah. So a is 1 over 2. Yeah. To find b, we just substitute the x coordinate here. A is an x coordinate back to the equation. So y of p will be, well, just b, right? Is just x 1/2 e to the minus 2 times 1/2. So that is just 1/2 times e to the minus 1, which is 1 over 2e, right? Just simplify that. Let me just double check here if I'm happy with everything. Yeah, I think I should be. So a equals 1/2 and b equals 1 over 2e. That's the answer there for A. Part B. The finite region R shown shaded in figure 3 is bounded by the curve, the line with equation y equals b and y and the y-axis. Okay, yeah, it's just that shaded region. B, find the exact area of R. Okay, so we're going to integrate. Well, let's plan a bit. If we integrate the curve, we're not going to get what we want. We're going to get the white area down here. But we can find the shaded area by using subtraction method. Maybe we want to find the rectangle first. Yeah, just the rectangle outlined by my cursor right now. And then we're going to subtract that area. We're going to subtract the white area from that area. So the area R will be equal to the rectangle. So the height of the rectangle is b, right? And the width is a. So it's just ab minus. Now we integrate that thing. Integrate the curve. So integrate, and then the limits will be from 0 to a. And then x e to the minus 2x dx. Yeah? So seems like we need to use by parts there. Yeah, that's fine. So that's it. So that's just AB, well, A times B is just 1/2 times 1 over 2e there. So that's together 1 over 4e, right? And then minus integral from 0 to 1/2, because A is 1/2. And then we have, I'm just going to make this u and make this dv, yeah, because usually that's the way to go. So what do we have here? We integrate by parts already. So in big brackets here, we have uv, which is x. Integrating e to the minus 2x, we get minus 1 over 2 e to the minus 2x, right? So the v is, okay, I'm just going to write the v minus 1 over 2 e to the minus 2x, yeah? Just reverse chain rule there. Okay. And then minus integral du, which is 1. And then also the v. So it's a minus here, so I can change the sign to a plus, right? Just make it a little simpler there. And 1/2 e to the minus 2x again. Okay, so it's 1 over 4e minus. simplifying everything and put the bounds all together. So I'm just going to write from 0 to 1/2 here. So that's minus x over 2e to the minus 2x. And then a plus, right? No, if we integrate that, again, we get, so the minus 2 will be dividing again. So we get a minus 1 over 4 e to the minus 2x, right? Yeah. And then this is from 0 to 1/2, okay? So, I mean, before we do anything, if we substitute, if we take the minus out, like if we factor minus 1 out, this is going to be a plus. So that will make the whole thing simpler. We should do that for simplicity. Yeah. Like that. So that's 1 over 4e plus, okay? So if we sub the first bound first, it's just e to the minus 1, so that's x is 1 over 2, so 1 over 4 e to the minus 1, which is e down here, yeah? All right, plus the second term, and that's the same, 1 over 4 e to the minus 1, yeah, okay? And then minus, right? The first term, there is no first term because 0 substituted into the x here, this one goes away. 0 sub in here, we get a 0 here, so that's 1. So that's minus 1 over 4 alone. That's it. So what do we have here? We have 3 of the 1 over 4e, so that's 3 over 4e, yeah? Minus 1 over 4. That's it, right? And that's the exact area of R. Are we happy with that? I mean, I could make it 3 minus e over 4e, like that as well, yeah? Okay, so I'm going to leave it at that. Is that? Yeah, that should be a positive number. Okay, just checking. Next question, number 10. Okay. A scientist is studying the flight of seabirds in a colony. She models the height above the sea level, h meters, of one of the birds in a colony by the equation. Okay, this is harmonic, right? Trig harmonic. Where t seconds, so h equals all that, where t seconds is the time after the bird leaves its nest, and a and t are constants. Figure 4 shows the sketch showing the graph h against t. Given that this seabird's nest is 20 meters above the sea level. Okay. A, find a complete equation for h. 3 marks. Yeah, so, right. So, because the bird leaves the nest at t equals 0, right? So, we just sub t equals 0, and that's going to be the height of the nest initially. So, this is just initial condition when t equals 0. So, we just say 20 equals 140 divided by a plus. So sine 0 is 0, cos 0 is 1, so that's 0 plus, minus 28. Because if you sub t equals 0 in there, you get cos 0, which is 1, so that's it. So we're going to solve for a. So a is just 140 over 20 and plus 28. Just solving for a there, guys. Nothing complicated here. So that is 35 meters, right? H in meters, isn't it? Yeah. Yeah, right. Oh, not yet. That is just a. So, we gotta find t as well. Complete equation. I'm just finding out if we want to find t as well. No, limitation. The limitation on the value of t. Yeah, I don't think we need to find t because this seems like it's going back up, right? Yeah. I'm just reading, hang on. Yeah, I'm just going to write h equals 140 divided by 35 plus 45 sine 2t degrees minus 28 cos 2t degrees, like that. It doesn't ask for harmonic function yet, harmonic form, so we're going to leave it like that. Okay? Part B. Given that blah blah blah, yes, now it's given us the harmonic form, so without any sweat, guys, we're going to use that. Find the value of alpha to one decimal place. Alright, so, well, I guess we're just going to have to expand the right side and equate it to part of the left side to find alpha. So if we expand the right side, we have 53 sine 2t cos alpha minus 53 cos 2t sine alpha, right? Just the additional formula of sine A minus B this time. Yeah, sine A cos B minus cos A sine B, if it's a minus, right? So if we compare the coefficient, we see that interesting. I mean, they don't look the same actually. All right, that's fine. So, okay. Yeah, all right. So cos 53 cos alpha is going to be equal to 45. Yeah, if you look at the first term and the first term on both sides. So cos alpha will be that. Yeah, if we do arc cos of that, we're going to get alpha in degrees. So we should change the mode to degrees, and then we do arc cos 45 over 53. That's going to be 31.891. Yeah, which is 31.9 to one decimal place. I mean, I'm just going to check for the other one, right, just in case. So if we equate the other one, it's going to be so 55 cos 2 theta. Wait, hang on. Oh yeah, 55 cos 2. So 53 sine alpha is the same as 28. So that would be arc sine 28 over 53. Yeah, that's the same. Just sanity check that. Okay, so B is done. Part C, find according to this model the minimum height of the seabird above the sea level, giving your answer to the nearest centimeters. Minimum height is just the turning point right here, but we don't need to differentiate. We can just use the logic of harmonic form here. So let's just get the form correct, like into the harmonic form. So we can see that the 45 sine 2t and minus 28 cos 2t here is just going to be 53, right? So that's just A was 35 plus, yeah, 53 sine 2t degrees minus alpha, which is 31.9 degrees, yeah? So that means if we want the minimum height, yeah, we want the minimum height, so this function will have to have the denominator of a maximum value. To make denominator maximum, we just put that to maximum, which is done by putting sine here to a maximum of 1. So h minimum, yeah, is going to be 140 divided by 35 plus 53 times 1. Yeah, the whole sine function there will become 1 to make this minimum. And that will be 140 divided by 35 plus 53. So that's just 35 over 22, nearest centimeters, right? This is, we got to be careful here. H is in meters. So that's going to be 1.59091 meters, which is, if we multiply that by 100, yeah, that's going to be nearest centimeter, so 159 centimeters. That's it. Yeah, don't fall for that, guys. D, the limitation on the value of t, right? So it kind of seems like the value of t here cannot go further than this very point, whatever that is. So if we try to make t go to infinity, right? Okay, so if we try to make t go to infinity, what do we have? let's see. Okay, yeah, there is a limitation there. If we consider our function again, this one. Okay, let's see. If t is too great, if t is great, what happens? Aha! So, yeah. So, I mean, there will be a point where the sine function will give you a negative value, right? And when that happens, for example, if we put this to -1, when this happens, this term will be minus 53, right? And that will make the denominator a negative number. What's wrong with that? Well, that means the whole h here will be a negative number, which is impossible. I mean, first, it's a height, so it's not a negative number. Second, it doesn't look like the graph will go to a negative part at all. So we can't have that. That means we'll just put 53 here. Sine 2t degrees 31.9 here. Equal to minus 35. Right? Because we want to find just that's like the critical value there. Because when you have that, it's going to go whoosh. Yeah, it's going to go high and high. So t cannot reach that maybe because you can't have division of 0, let alone the negative thing. Okay, so we're going to solve that actually. Yeah. So sine will be minus 35 divided by 53. Okay, yeah, probably have to solve that. So that's going to be arcsine, this is in degrees, so minus 35 over 53. Let's make that a positive value, right? Because if we get that, that doesn't make sense, right? It's going to give you a negative t. But this is basically solving a cast diagram. So negative sign, we get it. Wait, hang on. How do we? So we got to go this. We got to go this. So we want this angle, the first angle that it gets negative. So that's going to be 180 plus, right? So if we times that by -1 and plus 180. So that's going to be this angle right here, 221. So we know that 2t minus 31.9 is 221.3287. So t is just that 221 right there plus 31.9 equal, and then answer divided by 2. That is the limitation to the value of t. So t cannot be greater or equal. Can it be greater though? Well, I'm just going to say it cannot be greater or equal 126.6, right? Otherwise, we will have division of 0 here. Yeah, so that's like the bounds in second, right? Okay. Yeah, that's it. That would be my answer. Okay. Oh, we still have time, I guess. Number 11. Figure 5 shows a sketch of the curve with parametric equation, blah, blah, blah. The region R shown shaded in figure 5 is bounded by the curve, the x and the y-axis. Shown part A show that the area of R is given by that. All right. So this is parametric integration. That's just normal Cartesian integration. This is going to be integral y dx by dt. Yeah. And we got to change the upper and lower limits as well. So that's just y, which is 2 tan t, times dx by dt. Well, differentiating cos 2t, we get a minus sign. So a minus. And then you also do the chain rule in the 2t there. So you get a minus 6 sine 2t. And this is dt, of course. Yeah. Let's simplify this first and put the bounds later. So this is just minus 12. Yeah. So sine is just, tan t is just sine t over cos t, right? And then sine 2t here is just 2 sine t cos t, right? Yeah. So if I simplify everything, I get minus 24 integral So sine squared and the cos cancel that. So, oh, I should put 24 in there. Minus 24 sine squared t dt. I'm aware that the sign isn't the same, but before the bounds will have to be from 0 to the x-intercept here. So that means we need to find the x-intercept first. So x-intercept occurs at y0, yeah? So yeah, we can just find the bounds for t already. So this will be y at 0. We get 0 equals 210 t. So t at y equals 0, that is just 0. And no, y is not 0 there. So y0 here, what is 10? 10 of 0 is pi, right, isn't it? Hang on. Can't go to pi. Y equals 0. Hang on. Why is that pi over 4? I mean, if we put pi over 4 in the equation, we get 2. Interesting. Is there anything wrong with this? Okay, let's put pi over 4 in the x equation. We get cos pi over 2. Cos pi over 2 is 0. So that is saying, okay, yeah, all right, I get it. Okay, so if you put t equals 0 into the x, this is like doing backwards. X will be 3 cos 0, and that's 3, right? Yeah, but y is just what? I mean, the same value here, t being 0, so y will just be 2 times tan 0, and that is actually 0. So this is saying when t equals 0, the point is 3, 0, and that is the x-intercept here. Yeah, so the previous limit would be 0 to x, right? 0 to x. Yeah, so this is wait, hang on. Yeah, that's right. So x being 3 here and y being 0 here. Now at x being 3, right? So because we put in the manner of this, we got to follow the same manner. If we put 3 as the upper for the x here, I'm just going to write x equals 3 here and x equals 0 here. Then correspondingly, if you convert that to the t values, x equals 3 corresponds to t equals 0. So this is 0 up here. Yeah? And now let's put t equals pi over 4 as well. X will be equal to, well, if you put pi over 4 into the cos 2t, it will go to 0. Right? Because this is cos pi over 2, so that's 0. And y will be what? 2 tan pi over 4, that's just 2. Because tan pi over 4 is 1. Right? Just going to move down a little bit. Yeah? That's r. Now, so that means the correspondingly, the x equals 0 here will correspond to t equals pi over 4. So pi over 4 is down here. Now, because I mentioned about the negative sign earlier, because they don't have the negative sign here, that means if we want to get rid of this negative sign, the way to do is to switch the bounds, switch the limits. Yeah, and then it will cancel this negative sign. Done. Okay, so that is just as required. Okay, that's one way to go. Right. That's part A done. Part B. Now we have to integrate, I guess. Hence, using algebraic integration, find the exact area of R. All right, so classic. This is sine squared. It's not hard. You just have to know that cos 2t, yeah, the double angle formula, equals 1 minus 2 sine squared t. Okay? So if we make 2 sine t squared, 2 sine squared t the subject, we get 1 minus cos 2t, right? And then because we are integrating 24 sine squared t, so if I multiply that by 12 on both sides, yeah, I'm going to get 12 minus 12 cos 2t there. So that means r equals integral from 0 to pi over 4. From that, we change it to 12 minus 12 cos 2t dt, right? Okay, integrating that, yeah, so we get 12t minus integrating cos, we get a sine, and then we do the reverse chain rule, we get a 6 here because we got to divide by 2, yeah. All right, and then we sub in the bound 0 to pi over 4. Okay, I think that's fine by me, right? Yeah, and then we sub in the bounds. So the first one is, well, yeah, as you can see, if you sub in the lower limit, everything goes to 0. So we're just going to sub in the upper limit. So that's pi over 4 times 12, that's just 3 pi, right? Minus sine 2 pi over 4, so that's sine of pi over 2. Sine pi over 2 is 1, so that's minus 6. Yeah, and that's it. That's the exact area. All right, that's it for me. Next, question 12. What are we now? 1 hour 20 minutes. We're quite fine. Figure 6 shows a sketch of part of the curve with equation that the point P blah 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 lies on the curve. A, find the exact value of A. Right. Yeah, okay, so because point P lies on the curve, so we're just going to substitute the y coordinate here to find the x coordinate, right? So we just sub in 96 root 2 equals 3 times 2 to the power of 2x. Let's see. I mean, you can try solve this by an exponential equation, or you can take log, right? I mean, if you take log on both sides, it's going to be fine. But let me try show you how to solve it exponentially, right, using laws of exponents. So 96, right, isn't that just 16 times 6? Yep. And 16 times 6 is 2 to the power of 4 times 6. 6 is 2 times 3, so that's 2 to the power of 5 times 3. Yep, that's good. And then we also have 2 to the, so this is just 96, right? We also have 2 to the power of a half here. So if we add the power, well, I'm just going to write it 2 to the power of half, and 3 times 2 to the power of 2x. As you can see, the 3 cancel, right? And the power here on the left is just 5.5, yeah? So 5.5 is just 11 over 2 equals 2 to the power of 2x, yeah? So we equate 2x equals 11 over 2. So x is 11 over 4. That is just to solve it using laws of exponents or laws of indices. That's it. So that is just A, yeah? That's done for part A. The curve with equation that meets the curve with equation that at point Q. Show that x coordinate of Q is that. All right, so just solving another log equation maybe. Right, so I think I'm going to do the same way because I think you guys can do it logarithmically. But I'm going to do it, try it my way. So yeah, so 3 times 2 to the 2x equals, so 6, we know that it is 2 times 3, right? So, I mean, if you use this, ab to the power of m is just a to the m times b to the m. Because 6 is 2 times 3, so we split into 2 to the power of 3 minus x times 3 to the power of 3 minus x. Yeah? So if you, okay, what do we do here? Hang on. Right. Okay, that's tricky now. Okay. I guess I can't solve it like this anymore. I mean, okay, but we can make use of this. So I'm just gonna do 2. So if I divide that into that, I get 2x minus 3 minus x, right? Using the law of indices. Yeah, power gets subtracted when you divide them. And this one, so I'm going to divide that into that. So that will be 3 minus x minus 1. Simplifying the power here, I get 2 to the power of 3x minus 3 equals 3 to the power of 2 minus x. Right? And yeah, I guess we need to take log. So yeah, log base 2. So if we take log base 2, we're going to get 3x minus 3, and then log base 2 of 2 equals 2x, 2 minus x, log base 2 of 3, right? Just take log base 2 of on both sides. Well, that will be 1, right? We know. So, yeah, we got to expand. So 3x minus 3 equals 2 log base 2 of 3 minus x log base 2 of 3. If we merge the x term, we get 3x plus x log base 2 of 3 equals 2 log base 2 of 3 plus 3. If we factor the x out and then make x the subject, then we get this divided by, well, factor the x out, we get 3 plus log base 2 of 3. That seems to be the same. Yeah, I think we get it. Yeah, I think I got it. There you go, as required. X coordinate of Q. All right, so that's 12 done. Yeah, we have time. Number 3. Oh, wait, what? I'm finished. I mean, the paper is finished. Okay. I'm just have an hour and 25 minutes. I'm not gonna double check maybe because I think I did all the checking. So I'm just gonna mark the paper now. Let me just stop the timer. So this is the mark scheme for their mock paper. Let's check from the first question. You can also use it, go to the link in the description as well to go to this mark scheme. I'm just gonna mark myself against the mark scheme, all right? Okay, number 1, yeah, we proved that. 6, it's not the solution because log 3 cannot be found. Yeah, okay, got it. Number 2, yeah, we showed that. 8894, 8736, yeah. Attempt that, yeah. And then we got 0.003 here, yeah, I think that's fine. Got it. Number 3, yeah. 51.4 meters, 137.4 meters squared, yeah. Number 4, that. And then the coordinates. Oh, I've got to check B, sorry. B, yeah, B is just proving, so we got it fine. And this is just the coordinates. Number 5. 14 over 5, 2 over 5, that's fine. Number 6. Yeah, we got it. It felt weird when it's not an integer, right? You know what I mean. Yeah, nailed that as well. Number 7. A minus 2, B 7 over what? Is it a silly mistake? B is 3? Hang on, let me just do that substitution again. I got A right? So what were all the equations? Wait. Hang on. Okay, I got this fine. A was minus 2. This equation is not the same. Wait, that is a stupid mistake there. Oh, I see. This is not A over 4. Yeah, this is not A over 4. Oh man, sorry, it's not A over 2. It should be A over 4. Right. Yeah. Okay, and yeah, they all simplify. All right. So yeah, that should have been that. Right. Okay. Yeah. So this should have been A plus 4B plus 10. Sorry, minus 10 equals 0. So I got that equation wrong, but there is a method mark here. So let's see. Identify the fact that is a factor to deduce that. Doesn't seem like I need to arrive at the exact form here, so I think I'm fine with this. I think I get that mark. Except that the g derivative, I also got it. I sub that, and I got A minus 2. Yeah, I just lost 1 mark, basically. This one. B should be 3 instead, if I got that equation correctly. Stupid. Minus 1 here. Yeah, I should have checked, but there you go. Just one go without checking anything. Because I double check every time I do the question, but you know, sometimes it's not perfect, as you may already know, if you have seen many of my walkthrough. What about this one? Okay, so wait, yeah, so for the value of a and the temps, yeah, I plug my a value in. Wait, no, and attempt to show that it cannot equate 0. Yeah, so yeah, that's like less than 0. Yeah, I did. So for all x, the derivative greater than 0, so no stationary points. I mean, can't we just do discriminant? Can we not? What? Really? I mean, if we equal 0 and there's no solution, doesn't that work? Yeah, that should work, right? I mean, because this is a quadratic. If you solve for that, you get the solution. If there is no solution, there's no stationary point. That is just it. I think I kind of like disagree with the flexibility of this question here. Yeah, so I show that this cannot be 0 because it's less than 0, so no real root, so no stationary point. I think I got the marks here. Yeah, I'm gonna be biased to myself there for that one. But when I need to be harsh, I am. Yeah. Okay, so this one plotting. Yeah, I got the x-intercept there, y equals k for the asymptote, and the shape is right. Okay, and the range here, correct. Yeah, doesn't matter the order there. Number 9. Yeah, 3 minus e. I'm just going to look at the final answer here first. It seems correct, so what comes before should also be correct. Let's see. That's no part A. Is that? Where's part A? Okay, everything is just included in it. Okay, yeah, that's right. Number 10. 140, 35. Yeah, that's right. Good. 31.9. Yep. Now this one. Yeah, okay, I got this one, but the last one, I mean. Yeah, t cannot be greater or equal that. That's the same thing, because t cannot be greater or equal that, it means t is less than that, right? Which is the same thing. Yeah, same thing. Same, yeah, just in case you want to look at this later. And then number 11. Yeah, we showed that. I think we showed everything, and then we integrate 3 pi minus 6. Yeah, I'm fine. 12a, 11 over 4, and then we showed that. Oh, I nailed it. So I lost 1 mark from a silly mistake. Again, just an unacceptable silly mistake. But as you can see, I didn't go back to check anything, so I just took my chances. So I got what? 99 out of 100, guys. Yeah. Okay. And that was it. So please, if this is all useful for you, please like or subscribe or do both if you love me. And make sure you see the June 2024 walkthrough, yeah, for paper 2 here. And if the paper 3 is coming up also, don't forget to check that video as well. And I'll see you in there. Bye.